I'm Tom Norman, a BDM at Arrow, and I'm here with Joe from Broadcom. Joe, I just wanted to take a couple of moments to talk around private cloud, how that's delivering predictable costs. I suppose one issue is people have moved to the public cloud. How do they get back?
So
do they get everything back or not?
It depends what you've done, right? So the costing you started on is really interesting because a lot of the conversations we're having with people where they've got public cloud costs have got out of control. That can happen in different ways. It can happen in that just they ended up needing to deploy more than they thought they did, or someone deployed more than they should have done, or whatever, or costs have been changed, or the deal that they originally went on isn't the deal they've still got. So, typically people are spending multiples of what they expected to spend in the public cloud and looking further out long term, realizing they can't sustainably do that. I think when they now realize they can do that on-prem for a fraction of the cost, I'm talking half or a third of the cost for most of the workloads, that's when people really are starting to say, okay, private cloud's it, or a hybrid model. Yeah. I think that's really important to understand what do we mean by hybrid and that portability, and how do people move things across. We are seeing some repatriation. It's not huge, to be honest, but that's mainly because not an awful lot of stuff actually went to the public cloud. You go to most reasonable sized organizations, they probably only got 5 or 10% of their workloads into the public cloud. And the reason why they're focusing back on the private cloud is because they've realized it's staying and they've got to get it right, not that they've got to come back to it. But those that are coming back, obviously if it's a VM, it's quite easy. You can just move it back, right? If it's specific coding you've done to a specific proprietary part of a public cloud, then that's more challenging. And again, that's another reason why people are starting to come back out of the public cloud, is because they're realizing that they are coding themselves into a particular cloud, and that the cost of change is going to get greater and greater the longer they stay there. So people start to look at sort of those disintermediation layers. So it used to be VMs. I've got a VM, I can move a VM anywhere. Now it's up to the container level. If I build it in containers, then I can build those containers here, I can build those containers there. The challenge is if even with that, someone starts to go and build to a particular public cloud provider's Kubernetes, you'll find they've got little tweaks and bits that are just specific to their Kubernetes. That means it's not quite as pure and vanilla as to make it easy to come across. And so again, we're seeing a lot of people now look at how they start to extract their container-based applications, and they're starting to, I suppose, take the proprietary elements out of their coding that they've done to that version of Kubernetes to make it more vanilla. That's where we actually come in really well, because VKS, our own Kubernetes, is probably the most CNCF compliant vanilla Kubernetes there is. So when they start to pull it out of that, they realize, I can run it back on-prem, I can run it anywhere. So it really comes down to working out cost driving it to start with in most places, or maybe compliance. And then we start to say, okay, fine, well, where's the portability going to come? How can I move? And where's that disintermediation layer? If it's VMs, can I just drag and drop them, move them live in some cases, which you can do. Then the next layer up is, if it's container-based, how coded in am I with that? My YAML configs, are they very specific to a particular public cloud, or there's something I can change and bring back on-prem? And then you get higher than that, and that's when it gets really messy, because then you're into the SaaS stuff, which is quite painful to unpick.
Yeah, and your discussions with CIOs, CFOs, they'll often mention control, security, stability, those key words that are obviously massively high on their agenda. How does private cloud kind of get the reins around that compared to, say, public cloud, for example, a typical setup?
Well, I think there's no doubt they see the benefit. The reason why the number one reason people cite for coming back on-prem is security, realistically. Okay, it's because they know it's going to be something they can control, they can get their arms around, they can point to. In every essence, they're not beholden to anyone else for their own destiny. And I think that's really, really important to a lot of people when it comes to not just stuff for regulatory compliance or GDPR and other things, but just in applications that are important to their business. People are starting to bring them back on-prem.
And there's been some huge stories in the media lately. We'll not mention the companies, but companies that have been held to ransom, basically. Kind of how does, we know you buy security products that layer on top, but what's the kind of the base level security that's built into VCF, which helps people take care of their organization?
Wow. That's a big question. I mean,
it's not on the card as well.
No, it's fine. But I think it's important to understand that there's security built into pretty much every component that we've got. So if you look at individually, ESX itself, the hypervisor, look at the sort of 4 or 5 major components. So ESX itself, the hypervisor, that's been the most secure hypervisor in the marketplace since it first came out, and still is incredibly well trusted for doing that. And there's huge security controls that we built into that from the very, very start. So that's important. NSX. Well, NSX was virtualized networking that was the key to achieving inbuilt inherent security in your data center, right? It's the first one to properly introduce, scalable east-west traffic controls, way beyond what people are doing with the odd top of rack switch, right? You've now got, per container sets of firewall rules. I mean, that's just bonkers, right? So you've got that level of control there. Then obviously vSAN has its own, controls and security controls and encryption at rest and all the other bits and pieces that we can do with that too. So each component has its own individual security pieces. But when you get up to the automation and operations layer, that's where we really start to pull it together. Okay. Not only by hooking those together into one coherent platform, but providing the tool set to the operators and the deployers and the admins to be able to see in real time what their challenges are, where they potentially start to think about security differently. So I think it's more important to understand that what you're doing with that is you're providing one platform that's integrated from the silicon all the way up to the app developer, with everything underneath that all being tightly integrated.
So VMs, we've all heard about them. They've been around forever. Containers is a relatively new word that's surfacing. What's the difference?
So virtual machines have been around for a very, very long time. Virtualization on x86 since 1999 when VMware invented it, which is pretty cool. Containers equally been around for quite a long time, but really popped up in 2013, 2014 with Docker and what happened with them, with spinning that out of IBM. They're a very different way to do things. So a VM, you present it with virtual hardware, and in there you install an operating system, and then in that, on top of that, you then store the application. With a container, you don't really worry about the operating system part of it. Essentially what you'd get is you get a piece of hardware running Linux, for example, and then in there you'd install the applications. They're in little containers, and they get a tiny bit of operating system if you want to be simplistic about it. So they're quite different ways of doing things. So whereas in a VM, each one's got its own operating system, it can all be very different. Containers, they're all sharing an operating system. That meant that when we go to most customers now, they've got two different environments. They've got a virtualization environment for VMs, and they've got a container environment where they've built something out that way. You don't need to do that anymore. Where we are now in 2026 is you can have one combined platform. In fact, just the same way the public clouds do it. With VCF on-prem, we have one platform that runs containers and VMs natively side by side. And importantly, we run the containers natively directly on ESX. So they're exactly the same as if you ran them directly natively on a Linux, bare metal machine, if you want to call it that. There's no such thing as bare metal, but if you're running it directly on Linux, you can run it directly on that. So from a performance perspective, we've got containers and VMs side by side, performing as fast as they ever could, faster than they ever would in any other mechanism. But importantly, you've got one integrated control plane. And that integrated control plane also includes Kubernetes. So you can talk to and manage both VMs and containers with Kubernetes, but at the same time, you've got all the benefits that you've got with the sort of operational management layer that you get from virtualization, with all those hooks back to NSX and vSAN and all the different bits and pieces as well. So I think what you're really getting properly, truly, is the best of both worlds with VCF, is that you don't have to have a separate container platform to your VM platform. And that's really, again, you start talking about cost saving, that's huge, right? Am I operating a completely separate piece of hardware with a completely separate team just to support containers? Or have I got one contiguous platform on any hardware that I like that's operating both containers and VMs side by side on the same physical host? It's hugely powerful, but getting customers over that mindset of I need a different team for this and a different team for that is the same as trying to get them over I need a different team for storage, that I need for virtualization, that I need for networking or whatever. It's that starting to think about I'm a private cloud operator, I operate a platform, and that platform provides a series of services to developers or admins or whoever wants to come to it.
So Kubernetes, containers, seems inevitable, right? Eventually it looks like it's the future.
Oh, 100%. There's absolutely no doubt about that. If you don't have a strategy around containers, you don't have a strategy around Kubernetes, then really you are living a very, very long time in the past. The real kicker now is a lot of the ISVs that are selling you software will ship it in containers instead of shipping it in VMs. So you've got to have a container platform to run it on. It's that simple. Even if you're not developing your own cool, sexy stuff in containers, you need to have the ability to run containers because the stuff ships in containers. If you want to play in AI, all the models ship in containers. So you need to have that. So you need to start thinking about how you have a decent, coherent strategy around them.
Amazing. Thanks, Joe.